we are given two isotopes, and then we are asked to determine which of these isotopes are A, if they are isomers of each other, if they are isotopes of each other, if they are allotropes of each other, or if they are isoelectronic. Right? We are given two compounds here represented as an isotope format, but are they isotopes, isomers, allotropes, or isoelectronic? Now, the compounds or the elements are 8 and Y10. Now, we don't know the elements, but we know that the elements X and Y, meaning we don't know the elements, right? But what we know about them is that their proton numbers, like the atomic number, is 8 and the Y is 10. Also, the electron found in this, since Y is a neutral electron, it doesn't have a charge, the electron number is 10, and the electron number of this is initially 8, but since it has gained 2 electrons, it's now 10. First of all, let's ask ourselves, what do we mean by isomers, isotopes, allotropes, and isoelectronics? Isomers, these are molecules or a compound that have same formula for different structures in representing them, or different arrangements while representing them. So we can't say these two elements here, or these two atoms here, are isomers, because we are not representing them in any format, or they are not even a molecule or a compound for us to represent them in different formats. So option A will be wrong, and option B, we are asked if they are isotopes. Now, what are isotopes? Isotopes are atoms that have the same atomic number but different mass numbers. Now, you can see we are not given the mass numbers. Mass numbers of isotopes are always written at this corner here. We are not given the mass number, so we cannot tell if they are isotopes of each other. And also, they don't even have same atomic number, right? So they are not isotopes of each other. Now, the third one, option C, is allotropes. What are allotropes? Allotropes are the form, is a form in which an element exists in the physical state, right? So we have allotropes of carbon as well, diamond and graphite, right? But in this case, we don't even know if this particular element is carbon or is sulfur for us to tell if they are allotropes of each other, right? Now, I think the last option there should be correct. Isoelectronic. Isoelectronic simply means atoms that have different proton numbers, but they are, or different proton numbers, but the number of electrons found in them are the same due to loss or gain, or in a neutral state of those electrons. Now, you can see the proton number of X is 8 and Y is 10. But the electron number found in X here is 10, because initially X has 8 proton number, but since it has gained 2 electrons, it now have a total of 10 electrons. And also Y has 10 proton number, and since it's in neutral state, it also has 10 electrons. So they have same different proton number but same number of electrons. So this scenario is what we call isoelectronic. So X and Y are isoelectronic to each other. Thank you and bye for now.